Hi folks, we're going to take a look at question 10 from page 36. Let's take a look at the question. We have forces of 5 Newton and 2 Newtons and 12 Newtons all lying in the same plane acting on an object. So the fact that they're on the same plane means that we can draw all of these on the same sheet of paper. So the 5 Newton and 2 Newton forces lie on opposite sides of the 12 Newton force at angles of 40 and 20 degrees respectively, and we need to find the magnitude and direction of the resultant. Okay, since they're giving me the directions of these two vectors, the 5 and 2 Newton vectors, with respect to the 12 Newton vector, that's the one I'm going to draw first. So let's start, as usual, by drawing ourselves a diagram of what's going on. So we have this 12 Newton vector. No indication as to what its direction is, so I'll draw it horizontally to make my life simpler. And then I've got on either side of this vector, I've got a 5 Newton vector, okay, at 40 degrees from the original one, and then we have a 2 Newton vector at 20 degrees of the original vector. Okay, so what we'll do is we'll call this U, V, and W. Okay, so that we can keep things clear. So since we're adding 3 vectors, we'll start by adding 2, and then we'll add in a third one. And since we know by associativity the order does not matter, I'm going to start with these 2 vectors, U and V, which seem simplest. Okay? And notice here all the vectors were drawn tail to tail. The reason why I did that is because they were giving me the angles between the vectors. In other words, we need to draw them tail to tail. However, when I add them up, I'm not going to draw them tail to tail. I'm going to draw them tip to tail. So let me start with vector U and V. So here's vector V, okay, with a magnitude of 12. And then here at 40 degrees, I've got vector U with a magnitude of 5 newtons, and here 40 degrees. Okay, but in order to actually add them, I'm going to put them tip to tail. So I'll put vector U there, and here we have our resultant. Okay, now since we need an angle in the triangle, this angle between the 2 vectors is 40 degrees. Since I've moved over this vector, it's parallel to the original one, this angle will just be supplementary to 40. So this will be 140 degrees. Okay, and now we can find the magnitude of U plus V the way we've done many times using the cosine law. So magnitude of U plus V is just the square root of, and let's see what we got. We've got 5 and 12, so 5 squared plus 12 squared minus 2 times 5 times 12 times cos of 140. Okay, and let's calculate that here quickly. Okay, so square root, there's square root, there we go, of 5 squared plus 12 squared minus 2 times 5 times 12 times cos of 140 equals 16.15. Okay? But of course we also need a direction. Okay? So what I'm going to do is, since I've got this vector, the 12 Newton vector here, which is going horizontally, and I know, I'm sort of thinking ahead here, I know that my third vector also comes off the 12 Newton vector. What I'm going to do is I'm going to find this angle here to help give a direction. So here we got theta is equal to, so its opposite side is 5, so it's cos inverse of 5 squared minus 12 squared minus 16.15 squared all over negative 2 times 12 times 16.15. Okay, so let's again calculate that and make sure we do that very carefully on a calculator. Okay, so we've got cos inverse. Open up a bracket for our numerator, so 5 squared minus 12 squared minus 16.15 squared. Close the numerator bracket, divided by, open up a denominator bracket, negative 2 times 12 times 16.15. Close off the brackets, and we have 11.497, so even to 2 decimal places, that ends up being 11.50. Okay, so now we have this angle here is 11.5. Okay, so if I were to now add in vector W, which is 20 degrees, well, I can now determine the angle between my resultant vector, okay, the u plus v, which I've already added, and now I'm going to add to that w, and I see that the angle between those two vectors will be 20 plus 11.5. Okay, so I'm going to redraw this here. So here's my resultant vector, which had a magnitude of 16.15. Okay, and to that I've got my vector w, which of course has a magnitude of 2, and I know the angle between them is equal to 31.5. But again, I want to add these two vectors, so I'll move vector w out here, tip to tail. Okay, and there's the resultant vector. Okay, so this here is u plus v plus w. Alright, so I know that this is equal to 2. Okay, let's see what we have in terms of an angle. Okay, so we know that this was 31.5, but I need the angle inside the triangle here. So again, these two vectors are parallel, so they're just supplementary. Those two angles are supplementary. So let's do 180 minus 31.5. We've got 148.5. Okay, so now if I want the magnitude of u plus v plus w, it's just square root, again applying the cosine law here. So the other two sides are 2 squared plus 16.15 squared minus 2 times 16.15 times cos 148.5. Okay, so let's calculate that quickly here. Okay, so square root. Okay, and we've got 2 squared plus 16.15 squared minus 2 times 16.15, whoops, not minus, but times cos of 148.5. Okay, there we have 17.89. Okay, so we've got the magnitude of the resultant of all three vectors. Now I need a direction. Now it doesn't tell me, again, we don't have a fixed point of reference to work with, so north, south, east, or west. So I guess I'm going to give the direction of this vector relative to one of the vectors that I was given originally. Now the easiest one to use would be the vector w, because I already have that in my diagram here. So my goal is to find this vector alpha between vector w and the resultant. Okay, but this is the angle that I'm actually going to calculate, because it's inside my triangle, and I see a relationship that the angle I'm looking for plus beta is going to be equal to 31.5. So I can just do a quick subtraction to find this angle alpha. So let's start with finding beta. So again, I'll use the cosine law. Beta is cos inverse of, so the opposite side is 2, so 2 squared minus 16.15 squared minus 17.89 squared, all over negative 2 times 16.15 times 17.89. Okay, and let's calculate that here. Okay, so we've got cos inverse of, open up my numerator bracket, 2 squared minus 16.15 squared minus 17.89 squared, close bracket, divided by, open my denominator bracket, negative 2 times 16.15 times 17.89, close off my brackets, and we have 3.32 degrees. Okay, but remember, we were looking for the angle between the resultant and that vector w, so I'm looking for alpha, and alpha will just be the total angle of 31.5 minus this little angle that I found, 3.32. So 31.5 minus 3.32, and we have 31.5 minus 3.32 is equal to 28.18. So now I can give, let's show that here, I can now give my final answer. We have that U plus V plus W is equal to, okay, so we have our magnitude, 17.89. Okay, and the way I'm going to describe this is I'm going to describe this relative to angle W. So I'm going 28.18 degrees and I'm going in the counterclockwise direction. So I'll describe this as 28.18 degrees counterclockwise from W. Okay, and there we have it. So again, I was looking for magnitude and direction. Since there was no specific way to define the direction, I chose the one that was easiest, in this case here, relating it to the vector that was 2 newtons, which was the last one that I added. Okay, that's it for now.